Welcome to part 10, in our new game development series, focused on the 3D FLAX game engine, and the 6th in our specific Wolfenstein 3D game tutorial. Again, sorry about the delay between videos, but we were trying to implement the health system in visual scripting, and in the end, we had to drop the idea as we were facing an engine bug that made it impossible to do and forced us to go back to the C# scripting. In this video, we are starting to implement the player HUD and specifically the damage indicator with the face of the player character, and we are finishing the enemy state machine to manage damage and death. We were targeting to try to start implementing a procedural map, but we have to leave it for another video. So, without losing more time, let's jump into the tutorial. Let's start with the HUD. In Wolfenstein, the HUD has several functionalities, as it indicates the level currently being played, the score, and an inventory system, with the items that the player has with him. For now, we will only deal with the live level depicted by the animation of the player's face being increasingly more hurt. The first thing that we must do, is to import the sprite sheet with the face animations into FLAX, by dragging it from the source folder into the FLAX folder where you are storing your sprites. In the import dialog, choose for the size 256, and uncheck the compress and generate MIPS options. If you want, you can check the isAtlas function too. In our case, we will do it later. Go back to the source folder, and drag the HUD image into FLAX and repeat the import steps that we have done previously. In this case, the size should be set to 1024. Set the isAtlas checkbox. Once done, in the project hierarchy, select the UI canvas, and add below a new UI control and rename it to HUD. In the inspector on the left pane, click on the option Set Type and select Image. Then open the brush category by clicking on it. In the Type drop-down combo, choose Sprite. Open the Sprite option and from the project folder drag the HUD image into the Atlas field. In the game view, you should immediately see in the top left corner a small version of the HUD. Scroll down in the inspector until the transform option. Change the parameters for width, height, and scales until the HUD fits the screen. Let's repeat now the same actions for the player damage level. From the toolbox, drag a UI control into the project hierarchy below the HUD. This is because we want the face to render on top of the HUD. In this step by mistake, it was placed as a child of the HUD, we will fix it right next. Repeat the steps to make it a sprite. In the project folder, double-click on the face animations file and set the isAtlas option. Drag the image into the sprite field of the new UI control just created, and as previously, you should see the image with the 8 sprites in the top left corner of the game view. We need now to split the sprite sheet in each of its sprites, and for that, we need to double-click again on the face sprite sheet. Click on the default sprite to open its options. By default, both width and height are set to 256 by 256 pixels. In our case, our sprites are 64 pixels in width and 128 pixels in height, so, let's enter those options in the corresponding fields. Those are the values that we are using based on the sprite sheet used. If you have another one, then check your resolution to make it work. Let's rename also, the sprite. we will use the HUD plus the state level of the health. So, since the first face is for the character without any damage HUD 100. Let's create a new sprite. Resize again the dimensions of the sprite. The position will now vary in the X to 64 as we are trying to get the second horizontal image that is 64 pixels from the start. Remember that it is made correctly, you should see a blue bounding box around the selected sprites. Repeat the process until you have created all the sprites in the sprite sheet. Use the transform to place the face UI in the right spot at the center of the HUD. Let's move also the gun UI control to be above the HUD. Let's run the game to see what is looking. Not bad, it is almost feeling like Wolfenstein 3D. Now, we need to implement the code to manage the health UI. For that, we will be able to access the health status that we have placed in the player FPS script. So, that means that we will have to access it. The easiest way for that is by creating in FLAX a singleton. We have already covered different possibilities in a blog article on our website, which we'll post the link below in the description. Here we will just implement one of them. So, let's create a public static player FPS myInstance getter. We will only need the get. Inside it, we will check if a private instance variable is equal to null, in which case, we will find the version of the player FPS script currently active in the scene and save it in instance. We have not created the instance variable, so let's do it now as a private static FPS player. Let's now create the health script that we will be responsible for managing the UI element associated with the player face on the HUD. Let's define a couple of variables that we will need in the code. A UI control that will hold the reference to the UI control element. An image_image that will hold the reference to the propriety to where the sprites are attached to. A sprite brush sprite, that is the actual sprite element that is rendered on the screen and that allows controlling all the properties of the sprite. A sprite handle SPR, that is used to hold the index of the sprites to be painted. By mistake, we have typed sprite, although through the code we will use the right naming of SPR. A sprite atlas, that will allow us to access the different tiles in the tile set and know how many sprites are defined. An integer sprite atlas size to hold the number of sprites existing in the sprite sheet. In the onStart, let's grab the reference to the main elements in the UI. First thing is to get the reference to the main block, which is the UI control. We can do it by using the actor.as and the type UI control, and save it in the control variable. Now that we have the reference to the UI control, you can grab from it the image property and save it in _image by using the get method in the control variable. After this, we save the sprite brush of the image in the corresponding sprite variable and save the index of the sprites into the SPR variable. At this stage, we have seen a mistake in the name of the variable, that is SPR, and that we have defined as sprite above. So, if you have named it correctly, you shouldn't have any problem. Let's grab the reference to the sprite atlas and then its size. And let's initialize the index to 0, or the first sprite in our sequence of HUD faces. And let's render it to the screen by assigning the brush propriety of the UI control to the first sprite. After this, in the onUpdate, let's dynamically change the faces based on the level of health. For that, if the player is still alive, which is depicted by the level of health being above 0. Take note that we are using the singleton access that we have created earlier. Let's calculate the sprite that should be rendered to the screen. We have 8 sprites, so this means that we have to split our lives in the same numbers and use them to calculate the right sprite. Converting the health to a number between 0 and 8 is easy. We only have to divide by 10. Then, if we take the resulting number and subtract it from 8, we will be generating an index that will be moving from 0 to 8. With 0 being the character with a full life, and 8 the player with a low life. To make sure that, by mistake, we are not leaving the bounds of the sprites that we have, let's check if index, I, that we have calculated is below the number of sprites in the sprite sheet. If it is the case, then you assign it to the SPR index, which will be pointing to the right sprite in the sprite sheet, and use it to render it to the screen through the brush propriety. Let's check if the code is compiling correctly. It is always important to check at small intervals of time as to avoid too many errors. Well, we have some errors. Let's quickly fix it. The first error is that we have misspelled the brush propriety. It needed a capital B. The second error is the one that we warned you about earlier on. It is not sprite but SPR. The third error is that we have not used the keyword new when creating the new sprite brush object to render the current face to the screen. Now, it should compile correctly. Let's drag the health script into the UI control created for the player face in the HUD. Time to check if it works. The enemy is ferociously attacking and we can see that the face starts to change and progressively having more blood and being more bruised. Now, let's make the changes to the player FPS script and return the damage to the enemy. The first thing that we will do, is to reduce the health from 100 to 80 as to make the number of faces match the life level and improve the transition. Next, let's go to the shoot function where the player is firing the raycast that checks on if the enemy is in the line of vision. Since we have already implemented this code for the enemy, let's reuse it and copy it from the enemy soldier script. Paste it in the shoot function under the code that is checking if the raycast has impacted an object. Now, let's adjust the code to be working against the enemy. First thing, is to replace the tag from player to enemy. Then let's replace the get script from player FPS to enemy soldier as we will want to check if it is the enemy and access its health. Let's change also the type of the temp variable to the same type. Let's replace hit info with hit. Now, let's copy the take damage function that we have developed for the player and use it in the enemy soldier. Paste it in the enemy soldier script. If you are using debug logs to follow the execution of the code, replace the text to include enemy as to be able to be more easily traceable. To make it similar to the player, let's change the health level of the enemy to 80. Let's check if it is compiling without errors. Now, we need to make sure the enemy is correctly set to the right layers and tags. So, let's go back to the scene view. If we try to assign the enemy to the layer enemy, we can see that we don't have one. We need to create it. Layer and tags in FLAX are defined in the special interfaces for it, in the settings folder in the project directory. In the project folder, open up the folder settings and double-click on the layer and tags option. In the first empty slot type enemy and save. Add an enemy tag, save and exit. Assign the enemy to right layer and the right tags. If we are going to shoot at the enemy, we will need it to reflect the damage through a hit and eventually a death animation. Let's create it now. Let's go to the UI sprites folder, and open up the enemy sprite sheet. If you look at the sprites that are defining the hit and the death, we can see that the hit is only 1 frame, and the death is 5 sprites long. So, we need to define those new animations based on their corresponding position in the sprite sheet structure. So in the UI control that is used to create the enemy sprite, let's add 2 new animations. The first animation will be death that is 5 sprites from 60 to 64, no loop, and not rotated. The hurt animation will be only 1 sprite and should be sprite 67 or 68. Let's implement now the animations into the enemy soldier code. We will first implement them without a specific state machine to validate first the sprite's numbers and that all the animations are played correctly. Then we will move them into the existing structure of states that we have defined in the previous video. So, In the enemy soldier script, let's go down to the shoot function where we have already implemented a snippet of code for the shooting, and let's copy it. Next, let's go to the take damage function and paste the code. Replace the name of the animation with hurt. Move the code that is checking if the hurt animation is not being played to the first condition, and group the remaining instructions below it. So, if the enemy is not dead and is not being hurt already, we will reduce the live level and play the hurt animation. Let's go to the scene view and set the enemy to be on the enemy layer. Although we are not showing it here because of a crash with FLAX, the enemy's tag needs also to be set to enemy. Before testing the new code, let's add a debug output text showing that we are hitting the enemy and how his life is depleting. This way, we will know that it is being impacted. Let's run the game. And no, we are not damaging the enemy. We can see that the debug text is not showing in the console. We can also see that we have no visual indication of being firing because the gun is not playing any shooting animation, although we had one implemented. We will need to address this too. To make sure that we are hitting correctly, let's copy the debug draw line functions that we implemented for the player firing walls, and use them in the player shoot function to see if we are firing correctly at the enemy. We are also copying the condition of the raycast, just in case we are doing something wrong. Let's paste it in the enemy soldier take damage. Let's make some modifications to it, like making sure that it will be fired in the right direction, that the result of the raycast will be saved in the right variable. Let's change the color of the ray to green to make it different and easier to be seen. Let's define an attack range variable that will hold how far we can fire. Later on, we can make this a property of each gun, but for now, since we only have one gun, let's use it this way. We are going to initialize it for now with 100. Let's run the game. We can see clearly that the range of the weapon is not enough to reach the enemy. We need to increase it. Let's try 500. Let's check it. It seems that we can reach it, although the debug sphere that we implemented in the previous episodes is not being displayed. Let's continue forward by implementing the death when the enemy will have lost all its health. For that, in the take damage function, let's put a condition associated with health being less or equal to 0, in which case we will play the death animation and deactivate the actor. Our autocomplete is somewhat going nut and doesn't want to spell correctly actor. Let's also end in the play the angle of rotation that is 0 for the death animation. Let's try it. We can see that we are hitting the character. Let's see if it dies. Yes, it dies, because it disappears, but the death animation is not being played. Let's find out why. Let's review the animations and the sprites associated with it. We may be calling the wrong sequence of sprites. There is nothing else. We think that the animations are overlapping themselves and not giving time to be seen playing. The best way to solve this, and to put an order, is to finally create the two new states for hurt and death. Let's make the changes to the code and see it fixes at the same time the problem. Let's start by replacing the actual instructions for play the animations with Boolean variables that will hold the value of the state and will allow us to make the correct transitions. So we are going to use two new bool variables, is hurt and is death. So, if the enemy gets hurt, is hurt will be set to true. And if the enemy is dead, then is hurt will be false, and is death will become true. Let's declare the variables and set their initial state to false. Next, in the on update, let's introduce the two checks on the transition variables and call the right states. Do hurt and do death. Also, if we are hurt or dead, we don't want to execute any other state or instruction. Let's create the two functions starting by do death. Where we will be disabling the actor when the death animation is no longer running. In the do hurt, if we are not playing already the hurt animation, we will play it. But also, we will not allow more damage to be done for a certain amount of time, to avoid the animations overrunning themselves and giving an unfair advantage to the player. So, for that, we are going to use a variable hurt freeze time that will reset when more damage is allowed. Then, we are decreasing it with delta time and final when reaching 0, deactivate it and reset it to its original value. Let's define both the hurt freeze time and hurt freeze timer and initialize them to the correct values. We will start with an interval of 2 seconds. Before running the game, let's quickly fix a bug that we have seen while running the game. In a previous episode we disabled the fire animation of the player guns. So let's reactivate quickly and let's play it in our new shooting function. So let's run it. The pistol animation is running, and the player seems to be receiving damage, but the hurt animation is still being overrun too fast. Let's go back to the doHurt function, and let's rewrite it somewhat. Let's move the countdown out of the if condition. While we will be in this state, we will always decrease the time of the hurt freeze timer. Let's run it. Well, the hurt is not yet playing correctly. It is being overrun and we don't have a clue why. Let's try to kill the enemy. Okay, the death is running, but we will need to adjust its timing and how much time the enemy can stay in the ground before disappearing. This video is already running very long, so we will cut it for now and continue in the next episode. Will we be able to solve it? Will this enemy die properly? Will we get to 1,000 subscribers in the meanwhile? If we reach 1,000 subs, we will start to use the voice of one of the team members and drop the text-to-voice feature that we have been using for the last 6 months. Thanks for watching up to the end of this video, and we hope that you have liked it. If it has been the case, then don't forget to like the video. It is a good way to support our work and to make more people find us. Don't forget to subscribe and to click on the notification button, to be alerted for new weekly videos. If you have any request on where you want the tutorial to go, any questions, problems, or comments, don't hesitate in putting a comment and we will answer as fast as we could. See you in the next video, game developers.